2 notes over writing equations of parallel and perpendicular lines. Yesterday, or in day 1's lesson, we looked at slope-intercept form of a linear equation, y equals mx plus b. We graphed lines using this equation because you can easily see the slope and the y-intercept. We also looked at standard form of a linear equation, which is ax plus by equals c. We changed standard form of linear equation. We converted it to slope-intercept form of a linear equation and graphed lines that way. Today, we're going to be looking at point-slope form of a linear equation, which is written as y minus y1 equals m times x minus x1. We use point-slope form of a linear equation to write equations of lines when you're given information about the line, such as you're given the slope and a point on the line, or you could be given 2 points on the line. So let's label these parts of this form. Recall that an ordered pair is written x comma y. Y minus y1. This y1, what am I going to put right here? I'm going to put the y coordinate there. And I'll highlight this as well. So let's highlight it. So your y coordinate, you're going to put right here in point slope form of your linear equation. That's your y coordinate. Then let's use a different color here. Right here, your m, that's your slope, right? That's what's right there. So the slope, whatever you're given, if you could be given the slope of the line that you're asked to find the equation of the line, you could be given that, or you might need to use your slope formula to determine what the slope is. Then right here, x1, that's where we're going to put our x coordinate. Okay, so let's write that right there and write that right there. And I'm going to highlight it as well. Let's use pink. x1, that's where your x coordinate's going to go right there. Okay, so let's look at the steps that we're going to take as we write lines or write equations of lines. The first things that we're going to do is we're going to substitute the slope for m. We're also going to substitute our coordinates for x1 and y1, and then we're going to solve for y. So we're going to, and let's actually just get started on this, because honestly, when you start working through the examples, that's when you really it starts clicking. So the first examples are, we're going to write equations of lines when we're given the slope and a point on the line. So in this first example, we're given the equation of the line has a slope of 4 and it passes through the point 6, 16. So I'm going to label this x1, y1, and then I'm going to write the point slope form of a linear equation, which is y minus y1 equals m times x minus x1. And now we're just going to plug in things where they go. Okay, and actually I'm going to zoom out a little bit so you can see that point slope form of a linear equation right there. Okay, so the first thing I'm going to do is y minus, I'm going to plug in the y value right there. y1 is 16, so y minus 16 equals, then I'm going to substitute the slope, which is 4, right here, right? Which substitute, you're just replacing. Open parentheses, x minus, what's x1? It's 6. And now, so now we've plugged in these parts, the y1, the m, and the x1, and now we're just going to simplify this and solve for y. So y minus 16 equals, I'm going to distribute the 4 into each term inside the parentheses. So I get 4x minus 24. I'm going to add 16 to both sides, because if I'm converting to slope-intercept form, then I want to get y all by itself. So y equals 4x minus 8. Negative 24 and positive 16 makes negative 8. So y equals 4x minus 8. Let's move on to our next example. We're given a slope of 1/3. The equation of the line that we're writing has a slope of 1/3. It passes through the point 6, negative 3. And again, I'm going to zoom out so you can see point slope form of a linear equation. I'm slowly zooming out. Okay, point slope form of a linear equation. And it looks like this. Oh my gosh, my computer's moving kind of slow. So I'm going to label this x1, y1. I'm going to write this point slope form of a linear equation. So y minus y1 equals m times x minus x1. So y minus, I'm going to replace y1 with -3. So watch this. Y minus -3 equals, the slope is 1/3, x minus x1, which is +6. So in this example, I really like that the formula is y minus y1, and your y1 value is a -3. So that would be y minus -3, which is the same thing as y plus 3, equals, right? Minus a negative, you can change to a positive, okay? And I'm going to go ahead and distribute this 1/3 into each term inside the parentheses. 1/3 times x is 1/3 x. 1/3 times -6 is -2. And now I'm trying to get y all by itself, so I'm going to subtract 3 from both sides. And remember, you can only subtract it for the term that it is alike with, right? -3 is not a like term with 1/3 x, so I'm going to subtract it from -2. Y equals 1/3 x, -2, and -3 makes -5. And that's the equation of the line. So what we have done is we have written the equation of the line that has a slope of 1/3 and passes through the point 6, -3. Let's go on to our next set of examples. So I've got point slope form of a linear equation written again. This set of examples, we're going to be writing equation of the line given 2 points on the line. So recall that we were just given the slope and a point on the line. Now we're given 2 points on the line. So the first thing we need to do is use those points to find the slope. And we're going to use the slope formula to do this. So the slope formula says I subtract my y values, and then I subtract, or in the numerator, and then my x values in the denominator, right? So 5 minus 3, that goes on top in the numerator, over 4 minus 0. 5 minus 3 is 2. 4 minus 0 is 4. 2 over 4 simplifies to 1 over 2. So we have now found the slope of the line. So now we're pretty much back to where we were on the previous page. We know the slope. Now all we need to do is pick a point on the line. I'm going to go with 0, 3. Why do you think I'm going with this one? Because it's got a 0 in it and a 3. Smaller numbers, easier to work with, right? So I'm going to use that ordered pair right here. And then here's my slope. Y minus y1 equals m times x minus x1. And now I'm going to plug in the parts of this where they go. So y minus y1 would be 3 equals, slope is 1/2, over, or not over, times x minus x1 is 0. And now we're just going to simplify this and solve for y. So y minus 3 equals, distribute this 1/2 into each term. That's just 1/2 x. And that's all I'm going to be left with there, because 1/2, I don't get anything else, right? Times -0 or -0, minus nothing. So it's just 1/2 x. Now I'm going to add 3 to both sides, and watch how I do this. I'm going to add it over there because it is not a like term with 1/2 x. So y equals 1/2 x plus 3. That doesn't look like a 3. Let me rewrite that. 1/2 x plus 3. Oh, now it doesn't want to erase it. Okay, 1/2 x plus 3. Let's move on to example number 4. Example number 4 tells us that the line we're supposed to find the equation for passes through the points 12, 7, and -8, 12. So the first thing that we need to do is find the slope of this line. Let's use the slope formula to do so. Slope equals, let's subtract our y values, 12 minus 7, over -8 minus 12. So it's important to remember when we're using the slope formula that if we're doing 12 minus 7, we need to start with, in our denominator, -8 minus 12. Equals 12 minus 7 is 5, and -8 minus 12 is -20. This simplifies to 5 over -20 simplifies to -1/4. Now I have the slope of the line. We're going to plug in this slope and one of these points into point slope form of a linear equation. So we just need to pick a point. I'm going to use 12,7 as the point. And it didn't highlight. 12,7. There we go. Okay. Point slope form of a linear equation is y minus y1 equals the slope times x minus x1. So now we're just going to plug in our coordinates, x and y, and our slope, which is -1/4. So y minus the y value is 7 equals the slope is -1/4 times x minus the x value, which is 12. And now we're just going to simplify it, solve for y. So y minus 7, the first thing I'm going to do is distribute this -1/4 into each term inside the parentheses. So I get -1/4 times x, -1/4 times -12 is +3. I'm going to add 7 to both sides to get rid of this on the left side. Isolate y, get it all by itself, equals -1/4 x. Then 3 plus 7 is 10. And that's the equation of the line that passes through the points 12, 7, and -8, 12. Let's move on to the next section, which is horizontal and vertical lines. And I'm going to highlight it. What about horizontal and vertical lines? So recall, horizontal and vertical lines are just straight up and down or left and right. And let's look at the first one, horizontal lines. Y equals a number. That's every horizontal line is y equals some number, right? C is constant, right? It's just a number. So if I look at these 2 points, I notice that the line passes through the points 3, 5, and 6, 5. So I know that if I were to graph this, let's see, 3, 5 over left 3, up 1, 2, 3, 4, 5. And then 6, 5, that would be 4, 5, 6, and then up 5. Okay, I can clearly see my line looks like this. Every point on this line, every point on the line has a y value of 5. Let's write that down. Every point on the line has a y value of 5. Therefore, my answer is going to be y equals 5. That's the equation of the line. It has a slope of 0. Remember, those horizontal lines have a 0 slope. Let's move over to vertical lines. I'm going to zoom out just a little bit. Vertical lines go straight up and down. They're written x equals some number. It's written x equals c like a constant. A constant is just a number. And I can see on here that my x value for these 2 points is the same. If I were to graph these 2 points, -4, 2, 1, 2, left 4, up 2, or -4, 6, that would be left 4, up 1, 2, 3, 4, 5, 6, I can clearly see, oh, this is a vertical line, right? That's a vertical line. So x equals some number. Well, every point on this line, every point on the line has an x value of -4. If every point on the line has an x value of -4, the equation of the line is x equals -4. And that slope, recall, is undefined, right? Vertical lines have an undefined slope. So What the biggest thing that I see is students need to recognize, right? If you have, I mean, you can always do your slope formula here, in which case your slope would be undefined. Oh, I have a vertical line. You can do your slope formula over here and you would have a 0 slope. And you say, oh, okay, that's a horizontal line. The biggest thing that I see with these types of problems is just recognizing that it's going to be a horizontal or a vertical line. Okay, let's move on to the next set of examples. And now in the next section, we're going to be writing equations of parallel and perpendicular lines. And in this section, we're going to use the equation to find the slope of the line. So recall that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. Let's get started on your first example. Number 7 says to write the equation of the line that is parallel to y equals 3x minus 4 and passes through the point -4, -11. Remember, parallel lines have the same slope. In this case, the slope is 3, which means the slope of the line, or the slope of the equation of the line that you're writing, will also have a slope of 3. So now we're going to write our point slope form of a linear equation, and we're going to plug in slope of 3 and the point -4, -11 into point slope form of a linear equation. That's going to look like this. Y minus y1 equals m times x minus x1. I plug in -11 for y1, 3 for my slope, -4 for x1, and then you can see right here that x minus -4 is the same thing as x plus 4. So I've seen kids do this where they connect that minus the negative and make it a big plus sign. Now I'm going to distribute the 3 into each term inside the parentheses. So I get y, and here I went ahead and combined the minus -11, made it plus 11. 3 times x is 3x, 3 times 4 is 12. And now I'm going to subtract 11 from both sides, and I get y equals 3x plus 1. So the equation of the line that's parallel to this line and passes through this point is y equals 3x plus 1. Let's go over to example number 8. It says to write the equation of the line that is perpendicular to y equals 2x plus 5 and passes through the point 10, -13. Recall that perpendicular lines have opposite reciprocal slopes. So the slope of having a slope of 2, the opposite reciprocal slope would be flip it, take the opposite, it'd be -1/2. So now I need to write the equation of the line that has a slope of -1/2 and passes through this point. So we're where we were on our previous examples. So we're going to write point slope form of a linear equation. I'm going to plug in -13 for y1. I'm going to plug in -1/2 for m, and I'm going to plug in 10 for x1. And now I'm going to simplify this one step at a time. Y minus -13 I can rewrite as y plus 13. And then I'm going to distribute 1/2 into each term inside the parentheses. So I get -1/2 times x. Then -1/2 times -10 is positive 5. The goal is to get y all by itself because we're converting to slope-intercept form of a linear equation. So I'm going to subtract 13 from both sides, and I get y equals -1/2 x minus 8. In the next, or number 9, this is about as difficult as it gets, 9 and 10. It says to write the equation of the line that is parallel to 3x plus 2y equals 10 and passes through the point -6, 4. So what do you think the first thing is to do? I need to figure out what the slope is of this line right here. I can do that by converting it to slope-intercept form of a linear equation. Recall that parallel lines have the same slope. Now we're going to convert standard form to slope-intercept form for this equation. I'm going to subtract 3x from both sides. So I get 2y equals -3x plus 10. I'm going to divide this side by 2. Every term over here also gets divided by 2. y equals negative 3 over 2x plus 5, which means the slope is negative 3 over 2. Now I have the slope and I have a point that the line passes through. I'm going to plug it into my point slope form of a linear equation and solve. Let me walk you through this. Y minus y1 equals m times x minus x1. I'm going to plug in 4 for y1, negative 3 over 2 for my slope, negative 6 for x1. So that's x minus negative 6, which just is the same thing as x plus 6. Now I am going to distribute negative 3 over 2 into each term inside the parentheses. And I get, I wonder why that wasn't there, negative 3 over 2 times 6 is going to be negative 18 over 2, which is negative 9. So this should be negative 3 over 2x minus 9. And I've got it in PowerPoint slideshow form. So, I wonder if I can write that right here. Minus, let's do this, 9. It's not very pretty, but there you go. So y minus 4 equals negative 3 over 2x minus 9. Now I'm going to add 4 to both sides. So I get y equals negative 3 over 2x minus 5. Moving on to the next example. It says to write the equation of the line that is perpendicular to x minus 2y equals 4. Perpendicular, opposite reciprocal slopes. We're going to take this equation and we're going to solve for y. We're going to convert it to slope-intercept form of a linear equation. So I'm going to subtract x from both sides. Where's my little pointer? Okay. I'm going to subtract x from both sides. So I get negative 2y equals negative x plus 4. Divide everything by negative 2. And I get y equals 1 over 2x minus 2. So the slope of this line is 1/2. The slope of a line perpendicular to it would be negative 2. So now let's plug in, this is our slope, and this is our x1, y1. Let's plug it into point slope form of a linear equation. So I've got y minus y1 equals m times x minus x1. I'm going to plug in negative 1 for y1, negative 2 for my slope, and 5 for x1. And now let's distribute that negative 2 and combine the y minus 1. I don't know why you can't see my pointer. I wonder why. Y minus negative 1 is the same thing as y plus 1. I rewrote it. Negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10. I'm going to subtract 1 from both sides to get y equals negative 2x plus 9. Let's move on to our last page of notes. In the last page of notes, we're going to be writing equations of perpendicular bisectors. What is a perpendicular bisector? Maybe I can this one. Let's see. A perpendicular bisector is a line that is perpendicular to a segment at the segment's midpoint. So it splits that line segment in half. The steps that we're going to use, the first thing we're going to do is find the midpoint of the segment with the endpoints. And we're going to use the midpoint formula to do this. So let's look at our last example. It says to write the equation of the perpendicular bisector of the segment with endpoints. A is at 3, 4, and B, 1, 2. Let's use our midpoint formula. Recall that I add my x values, divide by 2. It's like the average of your x values. I'm going to add the y values and divide by 2. So I'm going to find the midpoint of segment AB. I'm going to label 3, 4 as x1, y1, and the point 1, 2 as x2 and y2. And then I'm just going to plug it into the formula, which is I'm going to add my x values. So that's 3 plus 1 over 2. I'm going to add my y values. That's 4 plus 2 over 2. All that simplifies to 3 plus 1 is 4. That's 4 over 2. 4 plus 2 is 6. That's 6 over 2. And now that simplifies to 2, 3. So now I found the midpoint of the line segment, right? Which is where that perpendicular bisector is going to intersect that line, right? So the next step is we're going to find the slope of the segment, and we're going to use the slope formula. So we're going to find the slope of the line, or the segment, if you will, that has these endpoints, right? So I'm just like finding the slope of that line, right? I'm going to use the slope formula, which is y2 minus y1 over x2 minus x1. So what does that look like? The slope of segment AB is 2 minus 4. I'm subtracting my y values. 2 minus 4. And remember, if I start with 2 and I go minus 4 on top, I need to start with 1 and go minus 3 in the denominator. 2 minus 4 is negative 2. 1 minus 3 is negative 2. Negative 2 over 2 equals 1. And remember, we're finding the equation of the perpendicular bisector. The slope of segment AB is 1, which means the slope of the perpendicular bisector is going to be negative 1, right? That's the opposite reciprocal. And 1 is just like 1 over 1, right? So the slope of the line that's perpendicular to it is going to be negative 1. And the next step, we're going to substitute the slope for M and xy for x1 and y1 in point slope form of a linear equation. So now I'm going to write I've got the midpoint, right? 2, 3, and I've got the slope of the line, which, the perpendicular bisector is negative 1. So what I have effectively found is the slope of the line and a point on the line, and I need to find the equation of the line that has this slope and passes through this point. So now I'm going to use point slope form of a linear equation, which is going to be the perpendicular bisector. Y minus y1 equals m times x minus x1. I'm going to plug in 3 for y1, negative 1, that's my slope, and 2 for x1. And here's the equation that I get. But I want to put it in slope intercept form. So I need to solve for y. So I need to first distribute negative 1 into each term inside the parentheses. So I get negative 1x, or negative x. Negative 1 times negative 2 is plus 2. Now if I get y all by itself, I'm going to add 3 to both sides. And I get y equals negative x plus 5. So now let's graph it. First, I'm going to graph segment AB, right? A is at 3, 4, so left 3, up 4, that's A. B is at 1, 2, right 1, up 2, that's B. It's a segment, and these are the endpoints. So it looks just like that. You can graph that now, and if you need to pause the video, go ahead and do that. So I can see the midpoint is going to be at 2, 3, that's right 2, up 3. The slope of the line for the perpendicular lines bisector is negative 1. So I'm going to go down 1 over 1 to the right, down 1 over 1 to the right, and it's going to look just like this, okay? So you can see this perpendicular bisector intersects this segment at its midpoint, which makes sense, right? It's just right there. And it's because it's perpendicular, it intersects it at a 90-degree angle. Okay, and this is the equation of that perpendicular bisector. Here's all the steps we took to get it. We used all of these formulas. And I would encourage you on your assignment to just follow these steps. Find the midpoint, find the slope, and don't forget the slope of the perpendicular bisector is going to be the opposite reciprocal of the slope of the segment. And then you just take those and you plug it into the equation of the line. But that concludes your day 2 notes over writing equations of parallel and perpendicular lines. I hope it was helpful.